So this is chapter 2, section 4, integer exponents. Here we'll be simplifying exponents with a negative or a zero exponent. So this is another algebraic example. B will represent your base again. And as before, this is just your factor. That will repeat. This time I put n instead of e. N stands for a negative exponent. And just like before, this negative exponent will tell you how many times to multiply the base to itself. Just so you know, we generally don't want to represent negative exponents. So the goal is to change it to a positive. Actually, there's an appropriate time to leave it negative, and there's an appropriate time to change it to positive. You'll notice what just happened. If you have a negative exponent and you want the exponent to become positive, we're going to write it as a reciprocal of itself. So instead of b to the negative n power, it's going to be 1 over b to the power of n. Of course, this will only work when b is not equal to 0. I also have one other I'd like to show you, and that is a base number to the zero property. I'm sorry, the zero power. Anytime you have a zero power, this will equal 1. And it doesn't matter what the base is. And I'll show you a good example of that right here. So what we're going to do is we're going to write the word exponent or exponential here. Just below that, we're going to write expanded. And then below that, simplified. I'm going to draw a line. And then I'm going to go across. Of course, you have lined paper, so maybe you don't need to do this. And for those of you using graph paper, you're probably in a better situation than the rest of us. So our exponent will be 10 squared. 10 squared is 10 times 10, and that equals 100. Okay, that's pretty easy. Alright, so then here's 10 to the first power. Well, 10 to the first power is just 10, and that's, well, just 10. Now notice how this went from 100 to 10. Well, here comes 10 to the 0 power. Now remember, anything to the 0 power equals 1, and that makes a great deal of sense down here. We had 2 zeros when we had 100, we had 1 0 when we had 10, and here we have no zeros. So this exponent is telling you how many zeros are in our simplified answer. This would also be 1, by the way. Now let's get to that negative exponent. Here's 10 to the negative first. So that'll be, and I'll have to squeeze this in here, 1 over 10. And that's just 1/10. So then we have 10 to the negative square. So that's going to be 1 over 10 times 10. 10 times 10 is 100, so that's going to be 1 over 100. Again, the exponent of 2 is showing you how many zeros are in the denominator. This 1 showing you how many zeros are in the denominator. The negative is telling you to write a fraction. And the last one we'll do will be 10 to the negative cube. So that'll be 1 over 10 times 10 times 10, and that'll be 1 over 1,000. That little chart could go a long way as far as getting yourself through assignments for the next couple of days. So now let's evaluate. Right, that's solving. So I have 10 to the negative fifth. If I want to rid myself of that negative, I'm going to write this as a fraction. 1 over 10 to the fifth. Then I'm going to expand that. So that's going to be 1 over 10 times 10 times 10 times 10 times 10. I'm not going to show you a shortcut here. I need you to understand each step process. I want you to see the transition of how this works. So the exponent is 5, so that means we have 5 tens, which means that our answer is going to be 1 over, and we have to count 5 zeros. 1, 2, 3, 4, 5. Put a comma there, and that's 1/100th. The decimal for this, if they ask you to go there, would look like this: tenths, hundreds, thousandths, 10,000ths, 100,000ths. Now let's try something that doesn't have a base of 10. Here is 5 to the negative cube. So the first thing we want to do is write 1 over 5 cubed. So now we have a positive exponent. Now we're going to expand. Might need a little more there. 5 times 5 times 5 under 1. Go ahead and multiply by pairs. 5 times 5 is 25. And 25 times 5 is 100. I'm sorry, yeah, 125. So that's 1 over 125. I'm going to try to keep these examples relatively easy. Just apply them to everything that we do. So this is 2 to the negative 6th power. So again, that's 1 over 2 to the power 6. Then that's going to be 1 over, might as well make this bar a little bit wider than before. We need 6 2's. And I have to stretch that bar out right there. Go ahead and multiply by pairs. 2 times 2 is 4, 2 times 2 is 4, and 2 times 2 is 4. I'm going to go ahead and write that down just because it's better visual. Now 4 times 4 is 16. And 16 times 4 is 1/64th. If you're at home watching this, feel free to pause the video at any given time. So we're going to solve this. This is 5 minus the quantity, 6 minus 4 to the negative cube, plus 2 to the 0. Order of operations. Order of operations. O cubed. So we start inside our parentheses. So 6 minus 4 is 2. Excuse me. 2. So now this is 2 to the negative cube. So we're going to change that to a fraction. That's going to be 1 over 2 cubed. This fraction is now a grouping symbol. If you remember, we talked about that. Grouping symbols are parentheses and then fractions. So we still need to take care of this 2 cubed. So 5 minus 1 over 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Alright, so we've simplified that. Now, 2 to the 0 power, we can take care of our exponent. So that's going to be 1, if you remember. And now we have to do some real work. So this is now 5 over 1 because we're going to make a whole number, a fraction. The least common denominator of 1 and 8 is 8. So we're going to multiply this by 8 over 8. It would be awesome if you actually knew how to subtract 1/8 from 5, and maybe some of you do, but I have a feeling that we're going to need to follow this process first. So this is now 40 over 8 minus 1 over 8 plus 1. 40 minus 1 is 39 over 8 plus 1. So now this is a great time. This is simplified. 39 over 8 is simplified, but we need to change it to something that we can use. So 8 goes into 39 4 times. That's 32. 32 from 39 is 7. So you have 4 and 7/8 plus 1. Now we just add 1 to 4, and the answer is 5 and 7/8. This stuff is tricky, there's no doubt about it. I will give you more examples tomorrow, but I'm just going to ask you to do your best with what you have. And like I said, tomorrow we'll go over this a little bit more. Good luck.